Hello, everybody. This is Mr. Chris, or Space Guy, as some people call me, from the Hudson Area Public Library. We are celebrating United Nations World Space Week. It started October 4th, and it ends tomorrow on the 10th. It is celebrated every year at this time, and I work with the United Nations on promoting this event. And I wanted to do an event for the library, and because we are in that kind of virtual programming mode, we are bringing it to you on our YouTube channel. So this is a recording I'm making today, and we'll get it posted up later today to kind of celebrate and give you some information on why it happened and what's going on. And I thought I would start right with my slides here and then show you some things after that. So World Space Week is October 4th through the 10th. It's sponsored by the United Nations, and so there's events happening this week all around the world, several different countries. A lot of people ask when I've done this before what it is, why is it happening, why October, all that. So let me get that out of the way right off the bat. So World Space Week is an event all around the world to promote education and information about space. They choose a different theme each year, and the reason for it is because we're kind of a worldwide global citizen science endeavor, and also to celebrate how many countries participate in the exploration and research in space. So a long time ago, there was only two nations involved in space exploration. You had the United States of America and the Soviet Union, which is now called Russia. Those are the only two countries that were capable of launching vehicles, satellites into space. And since then, it's grown exponentially. So we have countries all around the world that have space programs that assist other countries with supplying experiments and supplies and parts for their spacecraft if they don't launch their own rockets. And we have astronauts trained in several countries, and a lot of collaborative work that happens year in, year out around the world. Why does it happen on these dates, October 4th through the 10th? Well, that was not an accident. These dates were picked because they tie into two kind of famous anniversaries. So October 4th is the date that the first satellite was ever launched. That was Sputnik. Sputnik 1 was launched on October 4th in the late 1950s, and was launched by the Soviet Union, and was the first satellite, man-made satellite. The moon is a natural satellite of the Earth, an object that orbits around the Earth, and then a man-made satellite is one that is a spacecraft that is crafted by humans and sent up on a rocket and is able to stay in orbit around the Earth, and that is called a satellite. So October 4th, 1957 would be the anniversary of the very first satellite ever launched by mankind. And then October 10th is, in 1967, was the first World Space Treaty agreed by member nations that signed on the peaceful exploration of space. That it would not be militarized, that space, the moon or other objects would not be claimed for a country and fought over, that everyone would share their information, share the science, allow access to space. And so October 4th, the very first, and then October 10th being when the treaty was signed. So satellites, that is actually the theme for this year. We'll show this when we go back to full screen, but every year there's a theme and a poster, and satellites improve life is this year's theme. So satellites, a lot of people kind of heard about them. They may not know what they do and where they are and what they're about. So this could be a huge conversation, but I'm going to go into a few basic things, as you'll see here. So satellites can be broken into some of these major categories. Communications, and communications can entail voice communication. So when you've talked on a cell phone, often that is bounced off of and been relayed by a satellite, especially if you're talking to someone far away in another country. If you have relatives or family or friends that are outside of the United States, you've made a call, it's most definitely been relayed through a communication satellite. There's also visual information. So if you've watched movies, they could have been streamed or relayed by a satellite to you if you're watching them on Netflix or another streaming service. If you're watching a live broadcast, maybe a sporting event that's happening in another city or another country, it's being beamed and transmitted by a satellite. And then data transmission. So data we'll talk about later, but that would be anything kind of when you see all those numbers and information going back and forth on a computer screen. That could be measurements or distance or photographs or sea level rise or temperature, weather satellites, whatever kind of data they're sending in packets is also handled by satellites. Some of you may have seen, if you've watched the news in the morning or in the evening, you'll see the section where they do the weather report. And so they have a satellite that they're getting information from relative to our part of the country that would be showing the weather that's happening right now and the weather that might be coming, like especially we'll get in the winter when there's a snowstorm coming, they'll say 2 or 3 days from now, there's going to be this big storm, and they can show you that storm kind of moving across the country because we have satellites that are just dedicated to showing us what the weather is, and they're constantly staring at certain parts of the world to be able to give an accurate weather forecast several days in advance. GPS, a lot of you have used or been around. That stands for Global Positioning System, and that allows navigation to happen. So it started out as a military asset where it would help military planes and ships navigate to where they needed to go. And then it was later opened up to the general public. And so apps and cars and all kinds of communication avenues allow for GPS. So that's where if you've used it yourself or your parents, that's when you're typing in an address and the satellite will be able to figure out where you are by talking to 5 or 6 other satellites, kind of triangulating your position, and then it'll be able to navigate you to where you need to go that you've typed in for your destination. So that's obviously impacted a lot of people's lives. Imaging, we talked a little bit about a minute ago, but we'll talk about that in greater detail moving forward. Imaging is another word for saying taking pictures or measurements. And so that ties into several things. We'll talk about weather, land resources, military applications, things like that. And then environment. Environment is kind of related to the weather satellite data, but it's looking at different parts of the Earth and what's happening. So we'll look at some images where some satellites can even measure the amount of moisture that's in the soil. They can measure how healthy the forest is growing. They can measure areas of drought, dehydration, and kind of show those impact areas, all different kinds of spectrums they can be dialed into to give us information on that. And then military. Military, sometimes referred to as spy satellites, where the military has assets orbiting the Earth that are looking at potential conflict areas. And it's a way to keep eyes on a situation where you can see, as a country building up their military on the border with another country, are they moving military pieces around like they're getting ready for a conflict? And so it's a good way to kind of be apprised of what's happening and prepare for what might be coming in the future. So those are just some of the areas. You can break it down a lot further than that. And then this is a great image. This is published by NASA on the science fleet. So as it says in the title, you can see the operating in the future science fleet. So everything you see pictured are all the titles of and locations for spacecraft that are currently being operated by NASA right now, or they're about to launch in the next year or so. So you can kind of see they're grouped by where they are. We have 31 or so active satellites that NASA has operating right now, or will be operating in the very near future around the Earth. You see a couple around the moon. You have several around the sun. We have about 6 or so at Jupiter, several around Mars. And so satellites we think of in relation to the Earth, it's satellites that are orbiting the Earth, and those are all the ones you see there. They can also be satellites of another object. So the sun has these satellites where we're trying to get information and data on the sun and its activity each day. And we're studying planets, and we have satellites orbiting those planets to send us data back as well. So this is one of those photos that ties into the dates we were talking about before. This is the signing of the Space Treaty. So this was in 1967, October 10th, 1967. The man at the center of the photo is President Johnson, President Lyndon Johnson, who was president at the time in 1967. And then seated at the table are, on the left-hand side is the crew of Apollo 7, and on the right-hand side is the crew of Apollo 8. And they were signing the treaty as witnesses as well. So that previous photo, just to give you some of the count breakdowns, there was 31 satellites operated by NASA that are currently orbiting the Earth, 2 orbiting the Moon. We had 7 in Mars. The Sun has 21. In Jupiter, there are 6 that are orbiting or very near to Jupiter, just to give you a sense of some of the numbers. And then this is a photo of the other historic date. So this is a model of Sputnik that is at the Air and Space Museum in Washington, D.C. And it was about the size of a beach ball with these 4 large antennas sticking off it. And that was the October 4th date for that. So current numbers, there are 2,787 functioning satellites orbiting the Earth as of August 1st, 2020. So that's a lot. Some people are surprised by that number when you ask, how many satellites do you think are orbiting the Earth? And I've heard numbers on classroom presentations from 10 or 20, 100. Nobody usually guesses the actual number, which is 2,787. The breakdown on that, again, just to give you some of the big numbers, the United States has the most. We have just over 1,400 satellites. China, Russia, and then other. And other represents a whole lot of countries. So these countries have the largest share of satellites, the United States, China, and Russia. The other is broken into a lot of countries in the European Union. So you'd have Germany, France, England have satellites. You have several other countries around the world that have satellites, or they partner and jointly will launch the experiments on a satellite together to kind of share the cost. So there's a lot of partnerships, and that's why that 808 number kind of gets lumped into all the other countries that are helping each other with that. But those are the kind of breakdowns for the satellites that are operating right now and who's operating them. So weather satellites we talked about before. This is kind of a mosaic showing you some different weather satellites and what they do. There's a storm there, a hurricane. At the time I'm recording this, there is a storm headed for the Louisiana area on the Gulf Coast. I'm recording this on October 9th on a Friday, and there's a storm that's supposed to be making landfall this evening. So this is kind of timely because this is a mosaic of a weather satellite kind of monitoring a storm. You can kind of see the eye of the hurricane there below the satellite, and that's a great asset for us on satellites. They are up 24/7. They don't need to take a nap. They don't need to stop and eat food. They are looking at the Earth 24 hours a day, 7 days a week, all the time. And then as you can kind of see by this mosaic, that kind of represents that they're satellites all around the Earth passing at different times of day. So they're always getting a fresh look on what's happening below and then relaying that information back to the Earth. And the satellites can measure the wind speed or the rain content or the thickness of the clouds and the speed that the storm is moving and relay all that information back to weather people that are sharing that with all the people that might be impacted. So that helps with evacuations and emergency notices and allows planning for supplies or medical equipment or things like that. So it also helps a lot of things that you may have had experience with. It helps predict airline traffic, and if they have to reroute flights or cancel flights or delay flights. Shipping, there's always a lot of commercial shipping happening on the oceans all around the world 24/7, and this helps ships change their course to a safer route. If there's a storm coming that may damage the ship, they can reroute, still travel and get there, but they can go around a storm or go a different direction and not get in the middle of a storm. And then as I touched a little bit about evacuations, like what we may have this evening into this weekend with the storm that's coming up on the Louisiana coast, to warn people to board up their windows, to stock up on food supplies in case the power goes out, to head to higher ground or to drive further north in this case. And that's all by the benefit of having satellites that can give us that information. Landsat is the name of a satellite that I just want to show because it provides image breakdowns that you see here to the right. So this particular filter is showing things in red for healthy vegetation and moisture of the soil. And so everything that you're seeing is in red is indicating a healthy amount of vegetation and moisture in the soil. And the lower image is of the same area taken more recently, and you can kind of see the effects of the drought. It's using that same filter. And you see the vegetation area still, but it's not as prominent as the image up on top. And so you can see this is one way a satellite can give us information on what's happening in the soil, what's happening with the vegetation, not just a quick snapshot look flying over the top, but depending on which sensors and measurements you're using, can give you a lot more data on what's happening for an area. So this would help you, plan for drought contingencies, or that what kind of crops to plant if they're not going to be getting a lot of water. You want to plant crops that don't need as much water. So that's one example of the information. And then I have a few bullet points here just on what satellites can be very helpful at telling people here on the ground. So deforestation is a term for when forests are not healthy, kind of like this photo on the bottom, showing when you're starting to lose trees or trees are dying. Drought areas we just talked about. Flooding impacts. It can also show you the reverse, where if the area was saturated with water due to a storm or whatnot, it would show you super deep reds and purples on this kind of graph, indicating that the soil is actually overloaded with water and it doesn't have anywhere to go. And that can provide information to people on predicting flash flooding and things of the like. Health of the soil, we talked a little bit about. You want to see readings that are indicating that the soil is healthy and things are growing there and it has enough moisture. And then urban impact. Urban impact infers the construction. So if you have an area that's building a lot of highways and buildings, you can see the impacts. Is that hurting the neighboring forests? Is that putting too much pollution, more than we want? Should we redesign how we're putting in the roads to make it a little bit less impactful on the environment? This is an interesting image from a satellite, specifically New Zealand. And this is showing that kind of crack that looks like it's going from the top to the bottom of the screen is a fault line. This is a glacier kind of breaking apart in New Zealand, and is letting you know that the warm air on top and the warm water underneath was causing it to become unstable and to kind of break off. And this glacier will eventually drift to warmer water and will start to melt. And some of you may have heard about sea level rise. And so obviously, if you have all this frozen ice that you see and it goes to warmer water, it's going to melt when it gets to warmer water. And when it melts, it makes all the water go up to equal to the volume that the glacier is. So that's really good work for satellites to do, because they can fly over these uninhabited areas that would be too hard for us to get to with a vehicle or on foot. And it can provide information on, again, on a 24/7 basis and alert us of changes. So we also have satellites that measure the level of the ice, like the height of it. They have a laser that they can shoot down from space, and it can measure how long it takes for the laser signal to bounce back. And depending on how long it takes, it can sense that there's been a decrease in the height of the ice, because the laser light takes a little bit longer to return to the satellite than it did the previous month. They know that the ice has reduced by that much. And they could track the level of the ice, the amount of the ice, and the movement. So that helps us track what's going on with glaciers all around the world, which historically are very hard to track because of how remote and large they are. Another timely one in the news, this is from the California fires. It's been in the news a lot recently, if you've heard. A lot of fires in the west coast of the United States, Oregon, Washington, California especially. This is a fire in California, and you're seeing this from a satellite view. So this is the coast of California. You're kind of seeing the Pacific Ocean there on the bottom. And then you're able to see, obviously, the fire. And then all the area that you can see that's just that pure brown is where it's already burned. And you can see the green fields, farm fields, that have not been impacted yet on either side of the fire. So for fire detection, satellites can find the fires, the size of them, the direction, the speed they're moving. They can help direct resources, because the satellites can kind of get the bigger picture and see where the trends are going and what areas are going to be impacted next. So where to send, for instance, the helicopters or the airplanes that are dropping fire retardant, where to send fire trucks, things like that. And then as an aid to minimize future events, because from photographs like this, you can see, again, the areas that are damaged, the areas that have maybe a lot of dead vegetation that you can detect, and that could be a problem area because that could really burn if it's dead, dry wood. So that's going to be an area that you're going to want to clear out all of that wood and try to make that safe for future events. And then the International Space Station is a satellite. Some people don't think of that because it's occupied by astronauts. We usually think of satellites as an unmanned vehicle just observing the Earth, but the International Space Station orbits the Earth as a man-made satellite. You can see it here from Earth as it flies overhead if it's doing a pass in your area. And usually the space station has about 3 to 6 astronauts on it at any given time. So that's considered a satellite as well. So those are the slides I had to share. And then a few other things I have here. This is again, the poster. So I got these from the United Nations. So we have one of these up at the Hudson Area Library, and we have them up at every elementary school in Hudson. So if you're at an elementary school, you may see one of these up in the classroom or at the school. And with COVID-19, there was a little bit of delay in getting the posters out. Normally, I was hoping to have them out about a week or two ago, but I just got them out to schools today. So it's a good thing to kind of see the artwork that was submitted, and I hope it makes people kind of think about how satellites impact your life every day, because you may not think about it, but I'm guessing you've had interactions with satellites pretty much every day through using your devices on the internet, or if you're watching satellite television, or you have satellite radio in your car, or your parents have used GPS to go anywhere. There's been a lot of satellites involved in your life on a day-to-day basis. So a lot of fun things like this we're doing around. And I do love World Space Week. So some of the other things I wanted to show. So to get a satellite up, you need a rocket. So depending on the satellite, there's different rockets available to launch that. So if you need to get to a really high orbit, or it's a really heavy satellite, you need a larger rocket. It has to have more fuel, more energy to be able to lift your heavy, heavy payload up. If it's a lighter satellite, a smaller satellite, then you can get by with a smaller rocket and not need so many boosters to get it up to the altitude that you want to go. So you're starting with a rocket, and then the rockets are made out of, these are a little harder to share on video because I usually pass these around during a classroom presentation. But this is the skin of a rocket. This is how thick it is. So it's made, if you can see that, it's flight grade aluminum. So it's kind of like an aluminum can, if you've had a beverage out of an aluminum can, but it's obviously a lot thicker and stronger, and it's special aluminum. It's called flight grade aluminum, and I can't bend it no matter what. I can try as hard as I want, and it's not going to bend. So it's really strong, and it's really lightweight. If you've held an empty can, that's why it's a benefit for putting beverages in aluminum cans, because it's strong and it's really lightweight. And that's why they like it for making rockets, because it's strong and it's really lightweight, so it's not going to add to the weight of the rocket. But that's a piece of a Titan rocket that's pictured here that you could use for launching satellites. So I like to share the metal that they're used to be made of. And then I've got, where did I put them? Oh yeah. So then this is another physical model of a rocket we show in classroom presentations. So this is a liquid fueled rocket, liquid oxygen, liquid hydrogen. The satellite is up in what we call the payload fairing. So this is what protects the satellite until it gets into space. So all the wind rushing through, if it's raining that day, that'll protect the satellite you have in there. And then for this particular rocket, there's 4 solid rocket motors. You can almost think of those like fireworks. Those solid rockets give an added boost to the rocket when it first takes off, and they fall away a few minutes into the launch. And then the liquid engine provides the rest of the thrust to get up to orbit. Once it gets up into space, you don't need the fairing anymore that was just protecting it through the atmosphere of the Earth. So the fairing splits in half, and then it'll reveal your satellite. So for this example, I have a Lego satellite, which is something I use because kids like Legos, go figure, and it's kind of an easy way to explain. So this would be folded up inside that payload fairing, and then when the fairing splits open and falls away, it'll deploy its solar panels, if you can see those. So all satellites orbiting the Earth use solar panels because the sun is very close, provides a lot of light, and the spacecraft can get its power and charge its batteries while it's orbiting the Earth. So usually for a satellite will take about 90 minutes to orbit the Earth. So if it was flying over Hudson, 90 minutes later, it would go around the entire Earth and come back over Hudson. So for half of that orbit, about 45 minutes, it's in the sunlight, half 45 minutes in shadow. So for 45 minutes, it will charge its batteries on board. And then for 45 minutes, when it's in darkness, it'll run off of the battery power it's charged. It's kind of like if you've got a smartphone or a tablet, and if you're using it and then you need to charge it overnight, that's the same kind of concept. That's my bad metaphor for how a satellite works. So it can use its energy for the 45 minutes it's in the sunlight, and then for the 45 minutes it's in the darkness, it needs to run off the batteries that it was charging before. So that's how satellites work. So they usually have a small thruster on the back to modify their altitude, because they're always getting pulled back to Earth a little bit, so that they have to boost higher or change their direction. And then you'll notice a large communication antenna. So that's usually always pointed back at the Earth, so they can receive signals or send data back if they're beaming pictures down, if they're relaying your cell phone call, if they're sending an Avengers movie streaming down for you to see, they're relaying that. That's why the antennas are usually pointed down at the Earth. The solar panels are going to be in a configuration where they can charge in the sunlight, as I'm kind of demonstrating here by pointing to the lights I have here in the room. So that's a little bit about satellites, and that's just one of the things I wanted to share, since that's the theme for this year's World Space Week. And a few things we have at the library. We have a whole table of books out on satellites. If you want to learn more information about them, I have some NASA stickers and bookmarks out. As always, we have our STEAM take and make kits. I have some of those NASA calendars left that feature some of those photos that I showed of all the spacecraft that are currently operating in the solar system. So it's a fun week. I'll put a couple links here in the video description if you want to go check any of those out to get more information. And World Space Week is ending tomorrow. Tomorrow's the last day on Saturday. So if you wanted to check out the solar system walk, we have the inner solar system happening right now by the Hudson Arch. You can go down there and take a selfie. And we're giving out some prizes to people that post a selfie with one of the planets on the inner solar system. And then next spring, when the weather gets nice, hopefully March, April, we'll see how it goes. But when the weather gets nice enough, we're going to install the full solar system that'll start at the library and run all along the Riverwalk, starting with the sun and going all the way out to Neptune. So pretty excited about that. But I hope you find a way, either looking up at the sky and the moon, or seeing when you can spot the space station next, or checking out one of our cool books at the library. I hope you find a way to enjoy World Space Week. And thanks for watching the video. And again, like and subscribe to let us know that you are getting these videos, and we'll try to have something again for you on a STEAM take and make kit next week. Thanks a lot, everybody. Bye.